structure of atoms. In this particular lecture, we will be observing certain experiments. We'll try to draw out the conclusions and some important results. As we start, we should know that there were certain scientists, by the help of several experiments, who said that the atom is not the final indivisible particle. Rather, this particular atom was made up of proton, electrons and neutrons. Therefore, this particular atom had its own very complicated structure, which is made up of protons, neutrons and electrons. And these particular things, that is the proton, neutron and electron, are known as subatomic particles. So, subatomic particles are those particular particles from which an atom is made up of. That is the proton, neutron and the electron. Now, as we start, first thing we'll be observing the experiment which is called as the cathode. Cathode ray experiment. So I have already taken an liberty to draw this particular diagram here. Now, in the cathode ray experiment, this particular experiment was conducted by a famous scientist known as Faraday. So, Faraday was working on the electrical charges in a partially evacuated chambers, something like this. This particular chamber was built of glass. So, this glass, a partially evacuated glass tube, is called as the discharge tube. Right? Now, in this discharge tube, there were certain conditions, that is about the electricity, and certain condition about the pressure was to be maintained. Here, when this particular experiment was carried out, the two metal sheets, as you can see, one over here and the other over here, was connected to a high voltage. And this particular high voltage had a DC source. So, a high voltage was connected approximately of 10,000 volts. Right? So we are supplying 10,000 volts of electricity in this chamber of glass. Now, as soon as we start supplying such a huge amount of energy, what was happening was, in this particular chamber, there was glow of light. There was greenish glow of light that was operating. Now, as we set off our other condition, and the other condition was with respect to the pressure inside the discharge tube. The pressure inside the discharge tube was set to be 10 raised to minus 4 atmospheric pressure, that is by the help of vacuum pump over here. When they adjust the vacuum pump over here, what it does is it creates a vacuum inside the chamber, and the pressure is made less, or the pressure is lowered to a point of 10 raised to minus 4 atmosphere. That time, as the pressure reduces, the glow inside this chamber goes on decreasing. Okay, so when the particular glow goes on decreasing, yet one important thing that occurred, that continued, was there was a presence of electricity. That is, the electricity continued to flow from one terminal to the another terminal. Now, before proceeding further, I would like to tell you that the negative section over here is called as the kept because it has a unique property. That is, whenever any particular ray falls on it, it starts to glow. Okay, that particular thing is called as phosphorescence. That particular unique character is called as phosphorescence. So, in order to continue with this particular experiment, what Faraday did was he made this particular anode phosphorated. Now, phosphoration or phosphorated in the sense that this particular metal has holes. So what will happen is, whenever there is a passing of electricity, the rays were passing through these holes, they were striking this particular foil of zinc sulfide, and this zinc sulfide foil, as what we have here, it used to glow, showing or indicating that the some invisible rays were passing through the anode and it was striking the sheet of zinc sulfide. This is one conclusion that they gave. Okay, so moving further, after some time, there was another scientist, J.J. Thomson, one of the major contribution in this experiment was given by J.J. Thomson. Now, characteristics of cathode rays. Now, please remember that these all characteristics were given by J.J. Thomson because he took the same experiment, repeated several times, but he had his own conclusions. Now, what J.J. Thomson says is that whenever that there is an experiment being conducted, so we will have the first point over here. Okay, whenever this experiment was conducted, and if a substance is kept in a pump over here, something like this. Let's say there is a sheet of metal that has been kept over here. Now he says that as this particular rays were falling on the sheet, there was certain conclusion to be seen. That is, it provided a shadow. It gave rise to the shadow in the direction opposite to that of the flow of cathode rays. So, the first thing was, what we were saying is, it is going to impart shadow in a direction opposite to that of the cathode. First point. First point says that it imparts shadow in a direction opposite to that of the cathode. While here, if you observe here, that I have not placed any of the substance here, neither here. So, what is to happen is, in this particular condition, the gases used to glow or fluorescence used to take place. It's because these particular rays were traveling and there was a certain amount of gas, whatever it was there. Those particular gases used to get ionized and they used to glow in this particular condition where there is no material placed or where there is no blockage placed. So therefore, the first conclusion, what he says is, the cathode rays solution which was given by J.J. Thomson is that whenever there are radiation striking the small paddle which is kept in the direction of these cathode rays, those particular paddles will start to slowly rotate or slowly move, which is that it is exhibiting mechanical effect. Okay, so therefore, as we go further with the next one, whenever there is a magnetic field or an electric field, you already know that whenever there is a magnetic field, as in this case, or there is an electric field, let's say this particular thing is going to represent an electric field for us. Let us say this is the electric field, right? So whenever there is an electric field, we know that there is a positive charge and there is a negative charge. So therefore, if let's say this is a positive field of the electric section and this is a negative field. So these particular rays were slightly getting attracted or deviated towards the positive terminal of the electric or magnetic fields. Therefore, it was showing that these cathode rays were charged particles. Very important. These were the charged particles, and the charge present on the cathode was negative. Therefore, this is a negatively charged particle, which calls them as electrons. Coming forward to the next point. In the next point, what happens is if we are going to place simple metals over here, whenever these particular radiation used to strike a metal sheet kept in the way of their propagation, these particular sheets started getting heated up. That means it was producing a heating effect. It produces effect. Now, if we are going to keep over here substances on the metal such as, if we are going to keep metal such as tungsten, please observe tungsten, we give it as the symbol as W, or copper in this case. Okay, then what will happen is when the radiation, that is the cathode rays, are going to strike these particular metals, these metals exerted or they emitted X-rays. Remember, they emitted X-rays. So, if we are going to keep the metals such as the tungsten or copper, it usually emits X-rays. Next important point that we have already discussed is about whenever there are these particular cathodes and these are moving in a forward direction, and if there are gases in the path of these cathode rays, what will happen is these gases starts to emit radiation because of the ionization. That is, whenever the cathode rays will come and they interact or they collide with this particular gaseous molecule, these gaseous molecules were getting ionized. As they were getting ionized, they started emitting out radiation. That is, it started to glow. Therefore, the next point, what we can say is that these particular radiations, that is the cathode rays, were responsible for ionization of gases. Of course, there were other characteristics also, like if we are going to keep a photographic plate over here, it was also affecting the photographic plate. If we are going to keep a thin sheet of metal here, these rays were capable of passing through or penetrating through those thin sheets of metal, and therefore these rays can be stopped if we are going to use a metal of greater thickness. These are the conclusions